I want to show you how we can solve any problem that deals with roots using our fractional exponent rules, okay? And just a quick reminder, if we say we've got x to the b and we're taking the a root of that, that's the same as x raised to the b over a power. B is the power, a is the root, okay? The numerator is always the power, denominator is always the root. So let's do an example problem. Okay, when I see something like this and I've got kind of a weird root and power, first thing I do, rewrite it. So I'm going to write 2x to the 4/3 plus 9 equals 33. And then, as always, with any problem like this, I am going to save the x part for the very end. We're going to isolate it first. So I'm going to subtract 9 from both sides. I'm going to divide both sides by 2. Now at this point, I have x raised to the 4/3 power equals 12. We talked in an earlier video, or I talked in an earlier video, about the way we get rid of fractional exponents is by raising it to the reciprocal power, because 4/3 times 3/4, powers to powers we multiply, 4/3 times 3/4 is 1. So this is just going to become x equals. But whatever we do to one side, we have to do to the other. So 12 to the 3/4 as well. Now, what might be nice, since we started off with roots, would be to say, well, this is the same as the 4th root of 12 cubed. And then we could, type in 12 times 12 times 12 and figure out what that what the 4th root is. Or we could just type this into our calculator to have a decimal answer. 12 cubed is 1,728. That's kind of a nice exact answer. Yeah, we could take the root and actually get it. Let's do another example. All right, so here I have 3 times the 5th root of x minus 12 equals 39. Now, I chose this problem because you don't see a power. Please remember, if the power is not written, it's 1. So let's just make a pass through where we rewrite this as x to the 1/5. And now we're going to, once again, try and isolate the x part. I'm going to add 12 to both sides. So I've got 3x. I'm going to divide both sides by 3. So I've got x to the 1/5 equals 17. And the way I get rid of a 1/5 power is to raise it to the 5/1, or just 5 in this case. So x is equal to, if I type in 17 to the 5th, it's a huge number. It's over 1 million. Okay? So this is the way we can deal with crazy roots. Start by rewriting it with an exponent. Then isolate down to just that, and then raise to the reciprocal power. Let's do one more. All right, 2 times the square root of x to the 5th plus 19. Now, in the previous example, I said if there's no power written, we assume it's 1. If there's no root written, we assume it's the square root. So let's just rewrite this problem with a fractional exponent. And now we will, once again, isolate our x part. So subtract 19. Divide by 2. We have x to the 5/2 equals 40. Of course, the way we get rid of the 5/2 is the reciprocal, raised to the 2/5. So x is equal to, again, if you want to just write 40 to the 2/5, I almost prefer that because it's an exact answer. You could also write the 5th root of 40 squared. 40 squared is 1600, so you could write it's the 5th root of 1600. But I always prefer to have the answer written that way than decimals. But either way. All right, if this video helped you, please like and subscribe for more math help.